A heavy metal door opens. As soon as I step inside, I feel an unusual cold. Scientist Matthias Zabel, head of the sediment geochemistry group at MARUM, tells me this room is kept at plus 4 degrees Celsius, the average temperature of the deep ocean floor. In front of me stands a great library of the deep ocean. When you first walk in, it looks like a giant frozen archive, but it is not frozen, just cold. Scientists here sometimes call it a giant refrigerator. But inside these sediments, something extraordinary has been preserved. The climate history of the Earth.
Impact in. Arrival, contact in. All clear.
For more than 5 decades, scientific expeditions have drilled deep beneath the ocean floor, extracting sediment cores from different parts of the planet. And in the context of the climate emergency, scientists at MARUM are studying this archive to answer one urgent question: how fast can the planet change? Because according to Dr. Matthias, what is happening today may be unlike anything preserved in the geological record.
So this helps us at first to get information about former times in a specific area, but also of the timing of these changes, which is really important right now. What we all know, we have climate change, yes, obviously there, but for me, the very important question is very often how fast this goes.
The moment that door opened and I stepped into this frozen archive, I knew this had to be the starting point of the podcast. This episode is about that place and about the woman who has been its guardian for more than 3 decades. I am Juan David Escorcia. I report on the environment, the climate emergency, and the ocean, uncovering what's changing beneath the surface and what it means for all of us. This science journalism project was developed as part of the Frontiers Fellowship, funded by the European Union.
Part 1. The Memory of the Core Repository.
I'm Ursula Röhl, also known as Ulla, and I'm a senior scientist at MARUM, and I'm the head of the Bremen Core Repository Group.
And she has been here almost from the beginning.
We have something very special here in Bremen at the university in the MARUM, and this is one of only 3 international core repositories. This contains a very important collection of all the cores drilled over more than 55 years of scientific ocean drilling programs in the Atlantic Ocean, Mediterranean Sea, Black and Baltic Seas, and in the Arctic Ocean. And these cores by now accumulate up to 200 kilometers, and more than 350,000 core pieces are in our repository. And it's an important scientific hub for the international community to visit MARUM, the university, visit Bremen, and see the core, samples the core, talk to each other, collaborate with Bremen scientists, and so on.
She arrived at the University of Bremen as a postdoc. At the time, everything was much smaller.
Everything was much, much smaller than nowadays. And so I witnessed over more than 3 decades the development of the foundation of MARUM at some point, the foundation of the core repository, which started in summer 1994.
Summer 1994. That is when this story begins. A repository that today holds the material from 107 expeditions. But the question is, what exactly is inside?
But there are also a lot of cores from the deep sea, which on the first view look not too exciting maybe, because the human eye cannot tell variations in a given piece. So we call it mud. So there is gray mud and greenish mud and more mud and then kilometers of mud. It's an Earth history book, the collection of these cores, and then you can turn the page for page by resolving all the fine details which are recorded in the material.
Part 2. A brief history of 55 years of ocean drilling expeditions.
Every core in the repository was drilled from the ocean floor during a scientific expedition. And every expedition starts with a question.
Every expedition changed the knowledge in science, in marine geology, geochemistry, environmental changes, and so on.
These expeditions are part of what has been the largest international scientific program in earth sciences. And to understand their scale, we bring in another voice.
My name is Verena Hoyer, and I'm a senior research scientist at MARUM. I work in the Organic Geochemistry Group.
Dr. Verena has been involved in ocean drilling expeditions for more than 20 years. And much of the material she works with today is stored right here, in the core repository that Ulla takes care of.
The International Ocean Drilling Program is one of the largest projects in earth sciences that we have. And it started back in 1968 with a deep sea drilling program, which was started in the United States. After a while, they continued the program under a new name. It became the Ocean Drilling Program. And then there was a new phase that started in 2003, 2004. It was a phase of the Integrated Ocean Drilling Program. And at that time, the US, Europe, and Japan joined forces to build a big program together. And in the end, more than 24 countries were involved.
Part 3. What the Great Library of the Ocean Floor reveals.
So therefore we use sediment core records that show us the limit of the ice sheet, so basically the frontal moraine.
And how this was found in the sediment core and sediment cores around the world by measuring the geochemistry in a fossil, I found this fascinating. That some geochemistry in a tiny microfossil can tell you how the Earth's climate was swinging between cold and warm periods. And I found that fascinating. So that's what took me to...
But then, of course, we go in sediment cores, and with the sediment cores, we can look back in time. I mean, this is the big advantage here in the MARUM, because we have this big collection of sediment cores, and people are still going.
We don't know many places of the ocean. Actually, we know much better the Moon, Mars, as we know the deep sea floor, and that's why, especially because I'm focused on sediments, on the seafloor morphology, the first thing we usually do is go to a place with the ship, and we have to take a map.
These are the marine scientists here, speaking about the ocean sediments recovered from the seafloor. Remember each voice, because I will come back to them throughout this and other episodes. So the question is, what have these cores revealed? What have 55 years of drilling into the ocean floor allowed scientists to understand about Earth's past? To answer that, let me introduce you to Dr. Thomas.
Yeah, my name is Thomas Westerhold. I'm senior researcher here at MARUM, University of Bremen. Well, I'm a geologist, trained, but my profession is in paleoclimate reconstructions, mainly using deep sea deposits.
His research relies on sediment cores recovered through international ocean drilling expeditions. By analyzing them, he and his colleagues produced a continuous climate record spanning the last 66 million years, built entirely from ocean drilling cores, and he puts it directly.
I would say 2/3 of what we know about the planet and the climate is coming from deep sea drilling. And the only way to go further back in time is you go to the deep sea. And in the deep sea sediments, you find fossils that have incorporated to some extent changes in the ocean chemistry. This is related to temperature and ice volume change on the planet.
But the cores do not only speak about climate. Dr. Enno Schefuß, who tracks individual carbon molecules inside the sediment, sees the repository as something irreplaceable.
The answer that you get when you ask questions to the sediment core, for instance, right? And you say, okay, tell me about the history of what happened in the sediment core, right? And the questions you ask means the analytical tools, the way you ask, right? I mean, these sediment cores are used by many different disciplines of scientists. Some people look at the microfossils and they can tell something about the water column structure or something in the ocean. Some people look at the elements and then they tell about, oh, this is more terrigenous iron coming and this is more carbonate coming from the ocean. And these are molecular fossils, these organic remains, they are still relatively new. So there's always new discoveries of new molecular fossils. So we can still learn a lot about how are specific organisms reacting to specific conditions and what does it tell us how the Earth works, right?
How the Earth works. That is the answer buried in the mud. And the questions keep changing, even if the cores stay the same. Because a core drilled 20 years ago can answer a question that nobody had thought to ask when it was taken from the ocean floor. Dr. Verena describes the knowledge gap that still remains.
We have had a lot of wonderful science going on in the ocean for quite some time now, but still the whole system is so large and access is so difficult because we always need rather expensive infrastructure like research vessels or even drilling vessels. So what we know is really the tip of the iceberg. We know very little. And then if we go and look, we always discover something new. For example, with Expedition 501, this is the first time that we have discovered, really tapped into the fresh water in a continental margin setting. Before, we didn't know. And this is just one very prominent example, but the knowledge gap is still very big. And I'm concerned because the ocean floor as a system is still relatively undisturbed compared to ecosystems on land, but we are very ignorant about it.
Before we finished our conversation, I asked Ulla what she would like people to remember about this place.
They should remember about the importance of scientific ocean drilling, about what core archives hold for them. They don't need to remember me as person. And I'm not acting or working in a vacuum. I'm in first of all, a group, a team dedicated to it. And in the team, there are younger people, mid-aged people, a little bit older people, but all benefit from each other by exchanging what's going on in the world at meetings, strategic panel meetings about the program and so on.
That is Dr. Ulla, a geologist who has spent more than 30 years caring for a history book of the Earth written in mud, kilometers of it. And this episode is only the beginning, a journey into MARUM at the University of Bremen, where we will meet the scientists and marine research, trying to understand our planet in the context of the climate emergency. We will travel millions of years into the past to reconstruct ancient climate. Because understanding what happened millions of years ago may help us better understand this planet Earth. We will dive into the invisible ocean, where microscopic organisms and hidden processes quietly capture CO2 and help keep the planet in balance. We will follow carbon From the ocean surface to the deepest layers of the seafloor, searching for answers science still does not fully have. We will stand at the edge of glaciers, study traces of past warming preserved in sediments, and explore how the Earth responds when the climate changes. But beyond the science, this is also a journey into the lives of the people trying to understand the future of our planet. Scientists who dedicate years, sometimes entire careers, to asking difficult questions about the ocean, climate, and the world we are leaving behind. I am Juan David Escorcia. I report on the environment, the climate emergency, and the ocean, uncovering what's changing beneath the surface and what it means for all of us. This science journalism project was developed as part of the Frontiers Fellowship, funded by the European Union.